They're not uploaded yet. I didn't have time yesterday. Okay, as I was saying, multiplying rational expressions is really just an extension of simplifying rational expressions. The way we're going to do it is exactly the same as the way we simplify. The only difference is that instead of one fraction, we now have two. But your approach is going to be the same. We're going to factor, then we're going to cancel out common factors, simplify if we need to, and then finally list our restrictions. You're not actually really going to multiply. Alright, so let's started. So again, we're going to factor these just like we factored yesterday. So we need the factors of negative 6 that add up to positive 1.
3 negative 2.
5 and what? 3 and negative 2. Again, if you're not good at factoring, you must go practice. The website I put on the board yesterday has the worksheet I would guess has 20 problems at least. You do 20 problems of factoring, I promise you, by the end of that worksheet, you will be a factoring wizard. X minus 5 is already simplified, so if we can't do it. Does anybody recognize what this is?
Perfect square.
Difference of two perfect squares. So my factors are what? My factors are 5 and negative 5. And then finally the factors of 3 that add up to 4. What? 3 and 1. And since both my signs here are positive, I know that both my signs here are going to be positive. So again, this is exactly what we did yesterday. And in fact, the next step is exactly the same as what we did yesterday. The only difference is, instead of just canceling within one fraction, now we actually have two fractions from which to choose our canceling. And remember, this is multiplication. So in reality, what I have is I have one long string of binomials here, and another long string of binomials there. And the importance of that is, it doesn't matter where I get my binomial from. It could be the same fraction, but, see I have an x plus 3 here, and an x plus 3 over here. That's okay too. I can cancel them out across the multiplication sign. Similarly, I have an x minus 5 over here, and an x minus 5 over here. I cancel them out. I simplify. What I really mean by simplify is I combine whatever's left over. So what do I have on the top? I have x minus 2 and x plus 5. What do I have at the bottom? I have x plus 1. No. Okay, step number 4, my last step is to find my restrictions. And again, we're not just looking at the final result. We have to go back to the original denominators. I also feel that looking at this, it's very, very difficult to figure out what values of x are going to make this equal to 0. I wouldn't even want to try. So it's much easier to look at these factors, because looking at the factors, we can easily see what values make the factor equal to 0. So what minus 5 is equal to 0? 5. So one of my restrictions is that x cannot be 5. Here I have x plus 3, negative 3, and here I have x plus 1, negative 1. So I can't have it be 5, x cannot be 5, negative 3, or negative 1. Yes. Yesterday, we talked about that you can't divide by 0. Right? If you try dividing by 0, you get an error message on the calculator. So any number that x equals that makes a denominator add up to 0, we can't plug in as a solution. So here, what take away 5 is going to make this denominator 0? 5. So when I'm coming up a list of all the numbers that I could plug in for x, I can plug in any number that I want except for 5. And then I look over here, and I can't really figure out by looking at this. So what I do is I go down and I look at the factors. See, I haven't changed this. These two things are exactly the same. I haven't changed them. I've just changed the way that they look. So now I go ahead and I say, okay, well, what plus 3 equals 0? The answer is negative 3. And what plus 1 equals 0? The answer is negative 1. Okay, are there any other questions? Thank you. That was a good question.
Oh, I just understood calculating. Like, because it's basically like the reverse. Oh, okay. For some reason. Like, it's the reverse of, like, when you do FOIL, it's the same thing.
Right.
Yeah, I never realized that.
It's reverse is what.
Right, okay.
Okay. Any questions? Okay, what happens when I divide 2 from 2x? What's left over?
X.
X.
Minus
Bring my sign down, and then 8 divided by 2 is 4. X squared minus 16 is a binomial,
Yeah.
but it's got squared, the difference of 2 perfect squares. So the factoring of the difference of 2 perfect squares is x plus 4 and x minus 4. Okay, now we come over here. Now we have a trinomial. Now we are going to have 2 binomials. We need the factors of 4 that add up to 5.
X plus 4, X plus 1.
X plus 4, x plus 1, and then finally the factors of 16 that add up to 8.
X plus 4 and X plus 4. I'll let you say it next time.
Okay, now just be careful. Remember when you're canceling out, you cannot cancel out from the numerator only and the denominator only. It's got to be one from column A and one from column B. In other words, one from the numerator, one from the denominator. So, what can I cancel out? Well, I see a pair of x minus 4s, and I see a pair of x plus 4s. So what's left over? I get 2 times x plus 1 in the top, and x plus 4 times x plus 4 at the bottom. And then I look at my restrictions again. Here I got what? I got negative 4, I got positive 4, and these are the same negative 4s. So my restrictions are plus and minus 4. Because what value makes this add up to 0? What value makes this add up to 0? That's where I got it from. And since these are duplicates, we don't have to write it again. Once we write it once, it's negative 4 regardless of how many binomials we have. Okay, does anybody have any questions? Correct. dividing is the same as multiplying with one additional step. Because if you remember when we were doing the converging and the diverging, we had the fraction divided by another fraction, what was the first thing that we did? No. When we were dividing one fraction by another fraction, and I said we don't divide fractions, what did we do?
We multiply by the reciprocal.
We multiplied by the reciprocal. Well, guess what? Exactly.
Good job.
That's what we're going to do here as well. So the first step is to simply take the second fraction and flip it, take the division sign and turn it into a multiplication sign. So the first fraction stays exactly the same. My division becomes multiplication. X squared minus 1, x squared plus 3x minus 10. All I do is flip the second fraction and change the division sign to a multiplication sign. So you see, Lucas and others, it's exactly the same as what we just did with just one little additional step. No reason to get all jazz hands. What? What? Of course. But no, this says something. No, it's about complaining. He's not moaning and groaning about something. And anyway, so now we're going to factor.
Chill with the butts.
All right, so we factor. Can't factor 2 minus x, at least not yet. So we're going to leave it. Factors of 1 that add up to 2.
1 and 1.
Thank you, Jillian. A little voice.
Did I call you Julia?
Show. X squared minus 1 is what? And not x plus 1, x plus 1. What, Leticia? X plus 1, x minus 1. Again, this is a difference of 2 perfect squares. Okay, finally, the factors of negative 10 that add up to positive 3. Which one is my positive? Uh-oh, we have dissension. Who said positive? Who said 5? Gerard said 5. I want my answer to be positive 3. So the 5 has to be the positive number, otherwise I get negative 3 as my answer. Okay, now, this is, you look at this, and this is where you should maybe scratch your head a little bit and say, this looks weird. Why does it look weird? Because every other one of my binomials, the x is positive. So in order to fix this, we're going to make this x positive. How do we change a negative to a positive?
Multiply by -1.
Except in this case, we're going to divide by -1. So we're going to factor out a -1 from here. So instead of having 2 minus x, I get -1 times x minus 2. Again, I don't want negative x, so all I have to do is multiply this by, divide out a -1. In reality, all I'm doing is changing the signs and writing -1. Now, I can start canceling. Well, what do you see? I see an x plus 1 and an x plus 1. I see an x minus 2 and an x minus 2. Yes?
How did you get the -1 x minus 2?
This one?
Yeah.
You see how it's 2 minus x?
Yes.
See how all the other ones are all positive x?
Yes.
Well, I want this to be positive x.
Okay.
What can I do to negative x to make it positive x? Divide by -1. Right? Negative x divided by -1 gives me positive x.
Yes.
Okay? So I factor out a -1. And that has the effect of simply flipping the signs.
Oh, I see.
So my positive 2 becomes a negative 2, and my negative x becomes a positive x.
Okay.
All right? Okay, so what do I have left over? I have negative 1 times x minus 1 in the numerator, and I have an x plus 1 and an x plus 5 in the denominator. Okay, so far, no problem. Everything's been the same. The twist comes when we list the restrictions. Now, when can we have a 0? Or where can we have a 0? In the denominator. So for this, we not only have to look at the original denominators, but you also have to look at the flipped denominator, because we're multiplying. So you can't divide by 0 here, and you can't divide by 0 here. So the other difference between multiplication and division is instead of just looking at the denominators of the original fraction, now you're going to look at the denominator of the fraction on the left and both parts of the fraction on the right. Why both parts? Because we have a denominator here, which can't be 0, and then when we flip it, we have a denominator here that can't be 0. So when you start out with a division problem, you're going to have more restrictions than you would with a multiplication problem. So we still look here. So one of my restrictions is negative 1. So my first restriction is that x can't be negative 1. And now we're just going to look at these 4 instead of just looking at the bottom 2. So that's the only difference. We look at this whole fraction rather than just the denominator. So the numerator, I've got my negative 1, but I also have positive 1. So I have plus and minus 1. And then in my denominator, I have negative 5 and positive 2. So x can't be positive 2. X can't be negative 5. All right, so it's not a big twist. But just remember, when you divide, look at both parts of the fraction to get your restriction. Okay, does anybody have any questions?